All right, time for our last question. So here's our question. Again, step one is to find the GCF. So I'm going to go ahead and write that down. Looking at my numbers, 5, 25, and 70. My smallest number is 5. Does 5 go into all of these things? Yes, it does. So 5 is my GCF. Then looking at the variables, we have x to the 5th, x to the 3rd, and x. They all have at least one x. The smallest guy has just one x, so just one x in common. So I'm going to go ahead and skip a space, put my GCF on the outside, and a big parentheses. I'm going to divide each term by 5x. Okay, 5 divided by 5 is 1. X to the 5th divided by x is x to the 4th, because 5 take away 1 is 4. Positive 25 divided by 5 is a positive 5. X to the 3rd divided by x is 3 minus 1, which is 2. And then negative 70 divided by 5 is negative 14. And then the x's cancel. So here is my trinomial. Oh, but it's not of degree 2. So it looks like we can't factor it, but we actually can. So I'm going to rewrite this so that it does have degree 2. So degree 2 means I'm doing the same thing twice. So the same thing times itself. If I were to break this down, I could actually say x squared squared. So whatever this thing on the inside, that is to the second power, even though it happens to be x squared. Plus 5, and then now that this is x squared, this is going to be x squared as well, minus 14. So that's a little bit tricky looking at it, but it is kind of the most complex we do of these types of problems. So this really is, because remember, power to power, you multiply, so 2 times 2 is 4. This is just that. Okay, so with that being said, same exact process. I now do have something of degree 2 leading coefficient 1, so I'm going to go ahead and say 5x, and then my set of parentheses. And you're not going to do this process here. So I'm just showing you that it does satisfy it, but what you're going to do for your own self is you're going to say, so covering this up, you're going to say, what times itself gives me x to the 4th? What times what is x to the 4th? Well, x squared times x squared is x to the 4th. And that's what this thing inside here is. All the previous ones, we just had an x squared. So it's an x and an x. This one, the x squared is the thing on the inside. So that's just to explain it, but if that's confusing, just ignore that. How do I get x to the 4th? What times what is x to the 4th? Well, x squared times x squared is x to the 4th. Also, this should always match your middle term, because when I do my outer inner product, I'm going to have whatever x squared plus whatever x squared. Okay, so ignoring that for now, let's go ahead and do our little x method. Same exact process. What multiplies to be a negative 14 and adds to be a positive 5. Okay, the factors of 14 are 1 and 14 and 2 and 7. Well, I can easily see that 1 and 14 doesn't work. It's got to be a 2 and a 7. So I'm going to put a 2 and a 7 in there. Well, what kind of 2, what kind of 7? Again, the sign of the bigger is going to match. So I want a positive 5. So I need a positive 7 and a negative 2. 7 minus 2 is 5, or negative 2 plus 7 is 5. Either way. Double check your signs on your product. Is negative 2 times positive 7 negative 14? Yes, it is. So just plug these values in. So we have a minus 2 and a positive 7. And that actually is your answer. So I'm going to go ahead and box it off. But I'm going to go ahead real quick and prove to you that this guy does work. So taking down my GCF, I got a big long parentheses. Actually, I don't have a lot of space here, but that's what I got. X squared times x squared is x to the 4th. Negative 2 times a positive 7 is at negative 14. Now check your inner and outer product. Inner product is negative 2 times x squared is a negative 2x squared. Check your outer product. And again, I don't have enough space here. I apologize. So go in here. X squared times 7 is a positive 7x squared. So these guys have that x squared, which is that middle variable. Positive 7x squared and a negative 2x squared do give me a positive 5x squared. So I do have back what I just factored one moment ago. And then if you were to multiply this out, obviously multiplying by 5 is going to give you a 5, a 25, and a 70. And if you add an x to each of these, you're going to get x to the 5th, x to the 3rd, and just regular x. So you are going to get back that exact same problem you started with. So this definitely is the more complex of the problems. If you ever happen to have something weird like an x to the 4th or 8th or something like that, you just break it down into what times itself is going to give you that. Even x to the 6th. So just a random side note down here. If I had x to the 6th, well, what times what is x to the 6th? Well, that would be x to the 3rd times x to the 3rd, because 3 plus 3 is 6. Or you could say x to the 3rd squared. So you could really do any even power and actually be able to solve these problems. And you'll see those just sporadically throughout, but obviously this is the most complex of the questions. And last but not least are these things to remember. There is only going to be one answer that is factored completely. So no matter what you do, if you have factored correctly, meaning you've taken out the complete GCF and you've chosen them numbers properly, there is only one correct answer. But the order of the factors doesn't matter, which means, except for the GCF. The GCF has to go out front, but if you wrote x plus 5 and x plus 3, that is still correct. When we say there's only one correct answer, there is only an x plus 3 and an x plus 5. You cannot get an x minus 5 and whatever else. It can only be a plus 3 and a plus 5, but the order does not matter. You could have also had negative x squared y, x plus 5, and x plus 3. So same exact answer, looking for that positive 5 and that positive 3 in that correct GCF. But as long as you have those things, you can always check your answer and it will always give you back that same initial polynomial. All right, we're done.